Hi, this is Mr. West, and today we're doing a Kuta worksheet tutorial on the meaning of logarithms. So what is a logarithm and why do we need it? Let's work our way over here. I'm going to start with some easier ones to kind of demonstrate why we need logarithms. So here we have a simple problem, 5 to the x power equals 25. So what will x equal to give us 25? What could we raise 5 to get 25? So if you're completely unfamiliar, you could say 5 to the first power, I know that's 5 times itself one time. That's just going to give us 5. Okay, so that's obviously not it. If I have 5 to the second power, that gives me 5 times 5. That equals 25. I got it. Okay, so it's 2. X equals 2. That one's not so bad. Some of these are not so bad. But what about this? What power do we raise 5 to get to 30? You're probably saying, oh, there's no such power. Because if I do 5 to the third power, that's going to be 5 times 5 times 5. Okay, and then I get 125. So there's no such thing. But you can use decimals. So it's going to be 5.2 something. But what is it? That's why we use logarithms. Logarithms help us find x. There's no inverse operation like there is for other things. For example, if we have 2x equals 10, we do the opposite of multiply. We divide by 2. If we have x squared equals 100, we do the opposite of squaring it. We take the square root. Okay. Now, how do we undo this exponent? We use logarithms. So, for example, with this one, let me change to purple for effect. So we have log of base e of 30 equals x. See how we got the x by itself? And now we just need to punch this into a calculator, and this will tell us what the answer is. You can also graph this and find the answer also. There's a couple different options, but we're going to kind of stick with the calculator option today. But yes, this is the whole purpose of logarithms, is to undo those exponential forms. So the first step is we need to learn how to write logs in exponent form. So anytime you see a base of a log, it's this small number that's like a subscript. That's going to be the base of your exponent. And then the whole point of the logarithm is to get the exponent by itself. So that is going to be our exponent. So let me go ahead and label this. Here we have our base. Here you have the exponent. Okay, and then over here, I've seen it written two different ways. It's really called the argument. Okay, but I've also heard it called the number. Okay, so I'll put slash number. And this essentially is this. Okay, so equals 36. That's this number right here. So 6 squared equals 36. That's a true statement, right? If you square 6, you get 36. So that's how you rewrite it as an exponential equation. So here we have another one. We have 14 raised to the negative 2 power, and that's going to equal 1 over 196. And that's true, okay? These have to be true because it's an equation. Okay, over here, I'll just do these fast. We have 289, and if you raise that to the 1/2 power, that's the same thing as taking the square root. You're going to get 17. 3 to the 4th power equals 81. So you can see that this is really not too complicated writing it in exponential form. You just kind of have to know this. So if you're struggling with this concept, go ahead and kind of take this down as notes. Okay, maybe pause the screen, screenshot, whatever. I think that is important to know. Okay, so that's like your go-to. Let's go ahead and do the opposite. So we've gone one way. We always have to go two ways in mathematics. So how do we rewrite this as a logarithm? Anytime you have your base of the exponent, that's going to be your base of the log. So I have log of base 64. Okay, and then that's 1/2 is not there. That's the exponent. That's what we're trying to get by itself. We're going to put 8 right here. That's our argument, and then equals the exponent. Okay, so that's what we're doing for logs. So for this one, log, the base is 9, so the 9 goes in the base. We're going to actually transfer that 81 next to it, 1 over 81, and then equals negative 2. The exponent always goes by itself on the equal sign in exponential form. Log of base 12, or log base 12 of 144 equals our exponent 2. And then last one, we have log of base 112 of 1 over 144 equals 2. So that one looks ugly, but that's what it is. Okay, you got the exponents by itself, and there we go. Let's only do half of these upcoming ones. We're going to only do like a smattering selection of the following because I want to get to the last section. And the second to last section especially. Okay, So rewrite in an exponential form. So we just did this. We know that our base is going to be the base of the exponent. We know the equal sign is going to tell us what the exponent is, and then it's going to be equal to 15 over 16. We don't know what it is. We don't know what it's equal to because there's two variables, but we just need to rewrite it. Okay, base is going to be our base. The exponent is by itself on the equal sign. That's the whole point. And then our number is over there on the right. So our base is our base. There's our exponent, and then it's equal to our argument. All right, logarithmic form. Let's go ahead and do that. Our base is our base. Okay, that makes it easy. And then over here, we transfer and then equals our exponent in logarithm form. Our base is our base. I don't know if that's helpful if I say that over and over again, but it's what the problem dictates. So we have log of base 1/5 of y equals our exponent of x. And then log of 9, that's our base. Log of x base 9 equals y, our exponent. Okay, now this is the cool part. We're going to get into evaluating each expression. So essentially what we're doing is we're solving for x. We want to know what it's equal to. And I think it's helpful if we go, okay, what is 4 to the x power equals 64? So we can really consider either one of these equations, and that's going to be our answer. You can always find a logarithms calculator online. There's also like a table of logarithms, but I think we can do most of these in our head. Okay, so we have 4 to what power equals 64? Well, I know 4 squared is 16. And if I multiply that by 4 again, okay, so that's 4 times itself 3 times, it's going to give us 64. 4 to the third power equals 64. Let's just keep going down to the left side. Let's go see the right side too. Yeah, let's go to this one. This one looks harder. So I know 3 to the third power is 27. And then 3 to the fourth power equals 81. And then 3 to the fifth power, that's actually going to give us, let's just double check, 81 times 5. Nope, that's not going to be it yet. I think 243. Yeah, hold on. We're doing fine. So we get 5, and then we get 40. You know what? I don't think this is it. I don't think 81. Oh, I'm multiplying by 5, not 3. My handwriting's so terrible. All right, here we go. Times 3. You get 3, and then 24. Yeah, here we go. Okay, so that was to the fifth power. We get 243. Now, because it's in the denominator, that really means it's a negative exponent. So if I had 3 to the negative fifth power, that equals 1 over 243. It's important to kind of understand the powers of 3, and then you see it in the denominator, you know it's going to be a negative exponent. So this one is actually equal to negative 5. There's a lot of work for just a simple answer, but it's important. So we get negative 5 is that. And that just means 3 to the negative fifth power equals 1 over 243. Okay, let's keep going. A couple more. So this one's obvious. We just do to the second power. 2 squared equals 4. Over here, 5 to the third power equals 125. 7 to the third power equals 343. 4 squared. Okay, so a lot of these are pretty simple. Here's a good one. We have 64 to some power equals 4. Actually, I'm not sure. So let's see. If we do 64, I'm actually using my calculator for this. The square root of 64. Oh, this one is tough. I'm going to have to use you'd need a logarithm calculator for this, or another way we can do this, there's a trick around it, is we can go on our calculator, type in log of 4 over log of 64. This is implying a log. This is a little bit advanced, but this is a log of base 10. Anytime on your calculator you see that button log, okay, that equals base of 10. But this works. So on your calculator, you're going to type log of base 4, or not, log of 4, not a base 4, divided by log of 64. Okay, and that would give us, okay, so we get 0.3333. So that's going to be 1 over 3, 1/3. So if I take the cube root of, I should have been able to do that in my head, the cube root of 64, that gives me 4. 4 times itself equals, 3 times equals 64. So going in reverse, that'd be 1/3. That's a good problem, because then I showed you a new way that you can type it into your calculator also. Okay, so that's cool. All right, so we're going to finish up with these. They seem difficult. I bet they're not that hard. So right here, look at the exponent first. It says log of 144, base 12. So it's just saying, what number do you raise 12 by to get to 144? Well, that's 2. Okay, so we have 12 squared now. Okay, so instead of all that became just the number 2, because 12 squared equals 144. So now we have 12 squared again, and it's equal to 144. Okay, so for number 33, we see that we have log of base x 72 as the exponent. So essentially, I'm going to write this whole expression as an exponent. So take a look. I have this as an exponent. So my base is this guy right here. There's my base. So I'm going to change this as the base. And then I put y as just some unknown. I could have put a question mark here because remember, this is normally equal to some question mark. And then my exponent is all of this. So let me erase this. My exponent is all of this, and I put that in log form all over here on this right side. So take a look. You see that I have log base x of that question mark, that blank, is equal to log that same base equal to of 72. So we have to keep it the same on both sides. It's going to be 72. So this actually is equal to 72. This is one of the properties of logarithms. Okay, so it equals 72. We just need to rewrite it in logarithm form. Let me show you another way. So for this one, let's change the color. We have log, okay, and this is my base. This is my exponent. I need to put the exponent by itself on this side, log 517. And then I have log of base 5, and that's equal to question mark. Remember, equals to question mark, so I put question mark here. And I see that the question mark needs to match up with that 17. So this is going to equal, this whole thing equals 17. That's my answer. Now we're on to number 34, and you're going to see that this one's a little bit different because these bases don't match up. So we have log of base 9, there's our base, equals some question mark. We don't know what it equals. Okay, we could call it y. Let's go ahead and make it y instead. So log base 9 of y equals, and this is our exponent, so we can put our whole exponent over here on this right side, log base 3 of 20. So they don't have the same base. So this is going to be a slightly different scenario. So what I'm going to do here is I'm going to show you that we can do a different way, which is log of 20 over log of 3. We did this earlier. And I'm going to type that into my calculator. So I'm going to go log 20 divided by log 3. And that gives me 2.726833, so on. Okay, so I'm just going to write to 3 digits. And that equals log of base 9 of y. Okay, so now I know that I can just take 9 to the 2.726 power, and that's going to give me, I just converted this back into exponent form. So I'm just going to take this, I'm going to kind of store it in my calculator, go 9 raised to that power, and I'm going to hit enter and find out what it equals. And you see that when I do that, I get y equals 400. So you can see that this kind of, we stumbled into another concept, is if we squared that 20, we got that 400. So we saw that we had to square the 3 and square the 20 to have it match up, okay? And that equaled that 400. So kind of another logarithmic property. That would be another a video, a different type of worksheet. But yeah, that's all there is to it. So I hope you guys enjoyed this video. Make sure to like and subscribe if you haven't done so already. I have tons of other Kuta worksheet tutorials and tons of other content. Make sure to search it if you need more help. I look forward to seeing you next time right here on West Explains Best.